Space, often referred to as the final frontier, presents a complex and expansive realm that begins just beyond Earth's atmosphere and extends to the furthest depths of the observable universe. The atmosphere. Earth is surrounded by a blanket of gases, composed primarily of nitrogen and oxygen, which serves as a critical shield against solar and cosmic radiation while providing the essential elements of life. This atmosphere gradually thins as it ascends, reaching what is known as the Kármán line at about 100 kilometers above Earth, which marks the official boundary between Earth's atmosphere and outer space. Exosphere. The exosphere represents the outer boundary of Earth's atmosphere, where atmospheric density is so low that particles can travel hundreds of kilometers without colliding. Hydrogen and helium are the most common elements here. This layer transitions into the solar wind, a stream of charged particles ejected from the Sun. Low Earth orbit, LEO. LEO extends from about 160 kilometers to 2,000 kilometers above Earth's surface. It is a region bustling with human activity, primarily due to the International Space Station, ISS, which orbits within this range. Satellites in LEO are used for communication, Earth observation, and scientific research. The proximity to Earth allows for lower latency in communications and higher resolution in Earth imaging. Medium Earth orbit, MEO, situated between 2,000 and 35,786 kilometers above Earth. MEO is home to navigation satellites, such as those in the GPS constellation. These satellites provide crucial services for global navigation and timing, essential for everything from air travel to financial transactions. MEO satellites orbit the Earth in approximately 12 hours, offering a balance between the high coverage of LEO and the stability of GEO. Geostationary orbit, GEO, at about 35,786 kilometers above the equator, satellites in GEO orbit the Earth at the same rotational speed, making them appear stationary relative to a point on the Earth's surface. This unique property makes GEO ideal for communication, weather monitoring, and broadcasting, as these satellites provide consistent coverage to specific areas. Cislunar space. This term refers to the region encompassing the space between Earth and the Moon, including all the orbits around the Moon and the lunar surface itself. Cislunar space has garnered significant interest for future space missions, such as NASA's Artemis program, which aims to return humans to the Moon and establish a sustainable presence. This region serves as a potential staging ground for missions to Mars and beyond, offering a testing ground for deep space technologies. The Van Allen radiation belts and magnetosphere. The Van Allen belts are zones of energetic charged particles trapped by Earth's magnetic field, extending from about 1,000 to 60,000 kilometers above the surface. These belts consist of an inner belt of protons and an outer belt of electrons, protecting Earth by deflecting solar wind particles. The magnetosphere, a teardrop-shaped region surrounding the Earth, extends tens of thousands of kilometers into space, shielding our planet from solar and cosmic radiation. Interplanetary space. This vast expanse between the planets is filled with the solar wind, a stream of charged particles emanating from the Sun. This region contains the asteroid belt between Mars and Jupiter, where countless rocky bodies orbit the Sun. Interplanetary space is a dynamic environment influenced by solar activity, impacting space weather and affecting spacecraft and planetary atmospheres. The heliosphere. The heliosphere is a vast bubble-like region dominated by the solar wind and the Sun's magnetic field, extending far beyond the outer planets. It acts as a protective shield, deflecting much of the harmful cosmic radiation that originates outside the solar system. The boundary of the heliosphere, known as the heliopause, marks the transition to interstellar space. Kuiper belt. Located beyond Neptune's orbit, the Kuiper belt is a disc-shaped region filled with icy bodies, remnants from the early solar system. This belt contains dwarf planets like Pluto and Eris, along with countless smaller objects. Studying the Kuiper belt helps scientists understand the formation and evolution of the solar system. Oort cloud. The Oort cloud is a theoretical cloud of icy objects surrounding the solar system at distances up to 100,000 astronomical units, AU. This distant region is believed to be the source of long-period comets, which are occasionally perturbed by gravitational interactions and sent into the inner solar system. The existence of the Oort cloud remains hypothetical, as it is too distant to be directly observed. Interstellar space. Beyond the influence of the solar wind lies interstellar space, the region between stars within our galaxy. This space is filled with sparse gas, dust, and cosmic rays. Interstellar space is a frontier for future exploration, with missions like Voyager 1 and 2 already providing valuable data from beyond the heliosphere. Galactic space, encompassing all the stars, planetary systems, nebulae, and interstellar materials within the Milky Way galaxy. This region is home to our solar system. The Milky Way is a barred spiral galaxy with a supermassive black hole at its center, around which the galaxy's stars orbit. Understanding galactic space helps astronomers study the formation and evolution of galaxies. Intergalactic space. The vast expanse between galaxies is known as intergalactic space, characterized by its low density of particles and sparse matter. This region is mostly empty, containing only trace amounts of hydrogen and helium. Studying intergalactic space helps scientists understand the large-scale structure of the universe and the distribution of galaxies. Superclusters and voids. Superclusters are the largest known structures in the universe, consisting of groups of galaxy clusters bound together by gravity. Voids are vast, empty regions between superclusters. The study of these structures provides insights into the distribution of matter in the universe and the nature of dark matter and dark energy. Galactic halo. Surrounding the Milky Way is a halo of old stars, globular clusters, and dark matter, extending far beyond the visible parts of the galaxy. This halo plays a crucial role in the dynamics and evolution of the galaxy, influencing the orbits of stars and the distribution of dark matter. This journey through the different layers and areas of space not only underscores the vastness of the universe, but also highlights the diversity and complexity of the structures and phenomena within it. From the protective layers of Earth's atmosphere to the expansive reaches of intergalactic space, each region offers unique insights into the cosmos, continuing to challenge and expand our understanding of our place within it.